The polar vortex is a very large area of low pressure. It contains extremely cold air. This massive swirl of air sits high above the North Pole. It is a natural weather feature of our planet. The polar vortex is a normal part of Earth's atmospheric circulation system. You can think of it like a giant spinning top made of frigid air. Most of the time, this spinning top is well behaved and stays in its place. The vortex forms high up in the stratosphere, roughly 10 to 30 miles above the Earth's surface. It appears each winter season as the Arctic region cools down significantly. When the polar vortex is stable and strong, its winds are incredibly powerful. These winds consistently blow from west to east around the pole, forming a tight circular ring of air. This strong ring acts like a protective fence, trapping the extremely cold Arctic air. It keeps this frigid air contained near the North Pole, meaning regions further south experience milder winter conditions. The polar vortex plays a significant and natural role in shaping global weather patterns. Scientists have known about the polar vortex for many decades. Understanding its behavior is key for meteorologists to identify unusual or disruptive patterns. Its state is crucial for making accurate winter weather forecasts. Sometimes the polar vortex can weaken considerably. When this happens, it's normally strong, containing winds begin to slow down. The tight ring of air that usually holds the cold in place can become unstable. It is much like a perfectly spinning top that starts to wobble. This wobbling is often the first sign of potential problems for areas south of the Arctic. A weakened polar vortex rarely maintains its neat circular shape. Instead, it can stretch and become significantly distorted, sometimes splitting into smaller swirls of cold air. These smaller pieces can wander away from the polar region. The main polar vortex resides high up in the stratosphere, but its influence extends downwards. Below it, in the troposphere, is the polar jet stream, a fast-flowing river of air that circles the globe. A disturbed polar vortex can push and pull on this jet stream, causing it to develop large waves or dips. When the jet stream dips southward, it opens a pathway for frigid Arctic air to flow into mid-latitude regions. Places like North America, Europe, and parts of Asia can experience sudden and severe cold spells. These are the infamous polar vortex outbreaks responsible for bringing unusually cold temperatures and harsh winter conditions. They impact millions of people. The beginning of the year 2025 provided a clear example of the polar vortex's power. A significant winter storm struck large parts of the United States. Its severity prompted governors of 7 states to declare states of emergency. Heavy snowfall caused widespread disruption, leading to considerable travel chaos. Shortly after that initial storm, another wave of Arctic air descended upon the country. This second blast ensured that temperatures remained much lower than average for an extended period. The Midwest, Appalachian Mountains, and Atlantic seaboard shivered under this prolonged cold spell. January 2025 registered as the coldest January in the lower 48 states since 1988. This occurred even as the entire globe experienced its warmest January on record. Scientists pointed to a misbehaving polar vortex as a primary cause. The winter season of 2024 to 2025 was characterized by an unusually active polar vortex. It frequently stretched out of its typical shape, leading to multiple Arctic blasts. Some cities experienced record-breaking cold temperatures. Dallas, Texas, and New Orleans, Louisiana, were among those that felt this unusual chill. These events highlight the polar vortex's extensive influence on weather patterns far from the Arctic. Blocking highs are enormous atmospheric roadblocks. They are large areas of high pressure that move slowly or become stuck. When blocking highs park over a region, they disrupt the usual west to east flow of weather systems. This can lead to persistent and extreme weather patterns. During the winter of 2024 to 2025, a blocking high-pressure system established itself over Alaska and northwestern Canada. This high rerouted the path of the polar jet stream, forcing it to dip southward over North America. The already unstable polar vortex interacted with this blocking high, creating a pathway for frigid Arctic air to travel south. This combination led to severe and memorable cold spells. Blocking highs contributing to cold outbreaks are more common during La Niña winters. La Nina involves cooler than average sea surface temperatures in the equatorial Pacific. This pattern can influence weather conditions globally, including the behavior of the jet stream and blocking patterns. The winter of 2024 to 2025 fit this La Nina-influenced pattern. The Arctic region is warming at an incredibly rapid pace. It is warming approximately 3 times faster than the rest of the globe. This accelerated warming is a direct consequence of climate change. The melting of reflective ice and snow contributes to this phenomenon. As ice disappears, darker surfaces absorb more of the sun's heat, a process known as Arctic amplification. This rapid Arctic warming affects the behavior of the polar vortex. A warmer Arctic could lead to a more unstable or wavier polar vortex. A weaker jet stream might make the polar vortex more prone to disruption. More disruptions could mean more frequent outbreaks of cold Arctic air spilling southward. The scientific debate on this topic continues, highlighting the complexity of Earth's climate system. Looking ahead, we might see a mixed picture of weather patterns. Some predictions suggest that extreme cold events could become more frequent in the near term. This is linked to theories about increased polar vortex instability due to Arctic warming. However, as global temperatures rise, these cold events might become less severe. A warmer atmosphere can hold more moisture, potentially leading to more intense winter storms. We might experience extreme rainfall or heavy snowfall in certain regions. Despite potential short-term cold snaps, the long-term trend is clear: winters are getting warmer. This warming is driven by human activities, such as burning fossil fuels. While we might still experience cold and snowy winters, they will likely become less common over several decades. Climate change is expected to bring more unpredictable and extreme weather patterns. Milder periods could be punctuated by sharp, intense cold snaps. Understanding and preparing for these extremes is crucial. In February 2021, a severe Arctic outbreak struck Texas. This event was linked to a weakened polar vortex, allowing frigid air to plunge south. The extreme cold caught many communities off guard. Extensive power outages occurred as the state's energy grid failed. Millions were left without heat in dangerously freezing temperatures. Water systems were also severely impacted. Over 200 people lost their lives as a result of this extreme weather event. These past events demonstrate our vulnerability to extreme cold. Studying these cold waves helps scientists understand atmospheric behavior. This knowledge is vital for improving preparedness strategies. History provides invaluable lessons for facing the challenges posed by a changing climate. The term polar vortex is often misused or misunderstood. It is important to clarify that not every cold snap is a polar vortex event. A true polar vortex event involves a major disruption of high-altitude polar circulation. This allows extremely cold Arctic air to spill southward. Despite dramatic headlines, winters are getting warmer globally. This warming is driven by increasing concentrations of greenhouse gases. The occasional cold snap does not negate this overall warming trend. Scientists are working to better understand these complex atmospheric systems. The relationship between Arctic warming, the polar jet stream, and extreme cold events is an evolving area of research. More data and sophisticated climate models are needed to refine our understanding. This ongoing scientific endeavor helps us comprehend how climate change is reshaping winter weather patterns. The science is always advancing. The coming years might bring more frequent disruptions of the polar vortex. This means more sudden and intense Arctic blasts. However, the global warming trend suggests that cold spells might become less intensely cold over time. These changes will affect our daily lives and society. We need to be prepared for sudden deep freezes, even if winters are generally milder. Extreme swings in temperature can impact travel, schools, and businesses. Society needs to build greater resilience to this variability. Critical infrastructure must cope with future extremes. This includes well-insulated homes, robust power grids, and prepared emergency services. Investing in climate adaptation is a necessity. Understanding the polar vortex is crucial for facing future challenges. By learning, adapting, and preparing, we can navigate our chilling and warming future.